Hi everyone, today we're going to talk about reorder list problem from line 25 series. I think this is the third problem in the linked list series. So without wasting much time, let's get into the problem statement. So what is the question asked you to do is they will just give you a single linked list like this. You just need to reorder them. How we need to reorder is they just given a format. If you look at the question description, it might be a little confusing. So let me explain very easily. So what is a reordering? So how you have to do is you need to take an element. Pick an element from the first, and you need to pick element from the last. Okay, you need to pick this. First and last first. Just merge them, and then move to next node. Second and last second, which is the last second. This is then merge them, and then take third element and then last third element, merge them. That's it, very simple. That's what given like this. So L1 indicate the first element and n minus indicate last first element. Okay, last first element, and this L2 is the second element, and n minus 2 indicate the last second element. Let me repeat one time. You just need to pick element from the first and the last, just merge them, and pick a second element, pick a second element from the last, merge them. That's it, very simple. And it might be a little confusing if you read up the question, but just visualize this. Just take a first element and merge it with the last first element. Okay, that's what we did here. The output also like this. And take the next element, which is 2, and merge it with the last second element, which is the last second element, 5. So we merged it. And take the next element, then merge it with the last third element. That's it. 3 is merged with 4, and just return the output. That's it. Now if we talk about the initial approach for this particular problem, what we can do is simple. Simply we can just create an array from the given linked list. Just make an array. Convert this to an array. And the next step what we can do is we can implement the 2-pointer approach. One pointer will be there, one pointer will be there, and we can just simultaneously merge them very easily. For that, what we can do is we just create a resultant array. Okay, we just create a resultant array. Now pick the right element, left element, and push it to the list. So we just push 1, 6. Then move the pointers. Pointer will come here, and this pointer will come here. Now do the same operation, push the values 2, 5, then just move them value and then push them. Now what we're going to do is again convert this list to a linked list and just return it. This is the initial approach. Again, this is not a valid solution for this, but we can use this core logic and we can move to the optimized solution. Right now, if you see, the time complexity is going to be big O of n and the space is going to be big O of 1. We can do better. Okay. Always, as I said from the starting of this linked list problem, the most optimized solution is going to be comes from pointer manipulation. Now let's see, if you do pointer manipulation, this you don't need extra space. You can done within a constant space of one time. So now let's discuss how to do this. So what idea we got from the brute force solution is we're just taking a first element and merging with the last element. We are just doing it for n by 2 times. Remember, n by 2 times. We're just doing this only up to the midpoint. So if you come up to this particular point, the entire things has been done, right? So for a first time, we're just taking 1 and merging with the 6, then 2 merging with 5, and 3 merging with 4. We're just doing n by 2 times, which means you need to split the array into 2 half. Okay, the first half, this is going to be second half. That's what you can observe, right? So if you don't understand, just listen carefully, and now we'll see how this works. So first, as a first step, what we are going to do is we're just going to split into 2 particular half. Okay. Now what we did in the in a brute force approach, we just take a first element and merge with the last element. Now that is the list. Okay, so at the list we can just point it, we can just go backward, frontward. But how to do this in a linked list? How to do it? It's very simple, guys. We just reverse this half node. Reverse them, and we can start merging it easily. If you reverse this, the pointer will become like this, and you can simply take 6 and add it with the 1, and you can just move to the next node. It's very simple. So if you don't know how to reverse a linked list, you can watch this. I'll just give a high button. You can watch that and come back. So what the idea, just take a first half and a second half, and in the second half we're just going to reverse it. We're going to reverse the entire thing, and you can start merging it. There are only three steps in this problem. First step, we're just going to split into two half. We're just going to split into two half. The second step is going to be reverse the second half, and the third step, you're going to start merging the nodes. The merge node, this is the final step. And now let's see guys how to do this. And to split the array into two half, how can you do guys? Just tell me, how can you do? It's very simple. The most efficient way to split array into two half, it's using slow and fast pointer technique. Again, if you don't know slow and fast pointer technique, we have explained it in detail. You can see on a last video, which is detecting cycle in a linked list. So in there I explained slow and fast pointer technique. So if you apply slow and fast pointer technique, you will obviously end up in the mid element, so that we can split the array into two particular halves. So if I apply slow and fast pointer technique in this particular given node, it's going to be slow, fast. Next step, the fast is going to be two step ahead. Go back and watch the video and then come back here. And slow is going to be one step, and fast will go into two step, and slow is going to be go one step, and at this particular time we just go out of bounds. Now if you look at where the slow point lies, it lies on the midpoint. So you can apply the slow and fast pointer technique for this first particular step. Now we just split array into two particular half. Now let me draw this out. So this is going to be the first half guys, this is going to be a first half, and this is going to be a second half. Now what is the next step? We need to reverse this particular second half, right? So now let's do this. So you already know what is algorithm there. And now let's reverse this. I will directly write the reversal. It's going to be 6, and 6 map is going to be 5, 5 map is going to be 4. This is how it will look after the reversal. Now what is the next step? This is a very important step guys, so please pay attention for this. You need to merge them. How to merge them? Let me show it to you. So what we're going to do is, for merging part, same two pointer approach. We're just going to have one pointer here and one pointer here. What we're going to do now? You're going to take a first pointer. Okay, this is a first pointer, right? You're just going to take first pointer and map it with the second pointer, which is 6. I mean second node. Now what do you have to do? You have to put back an array, right? This thing must become this particular side. So again, put this back. 2, 3. Now you have to move the pointers. So go this, and it will come here. And you can ask me how can I preserve this? That's very good question. What we can do is, you can, let me go back. If I go back, yeah, this will look like this, right? So what we can do is, you can typically store this in a temp. Temp 1. Same for this. This is going to be stored in a temp 2. What we can do is, let's say this is going to be n1 and n2. A simple formula. So n1 dot next is going to be n2. Now what is the next step? You have to map n2 dot next to this temporary, right? Then only this will come next to this. Am I right? What is the next step? n2 dot next is going to be temp 1. It's very simple. I hope you guys understand this. What we are doing is, we're just merging node 1 to node 2, and after merging, what you have to do is, you have to put back the remaining element, right? That's why I'm just mapping temp 1 to the node 2. If you look at the formula, first node, the last first node, and after that you are having the second node, right? That's why we're just preserving this thing and merging after this particular step. I hope you understand this thing. Now let's continue the process. This is the core merging feature. Now as usual, now we have to move the pointers. So temp n1 is going to be temp 1. Now n2 is going to be temp 2. That's it guys, very simple. This is the entire code, and remaining codes are already you know how to write fast and slow pointer as well as the reversal code. For our problem, this is the main logical code. So now let's continue the process. Now the pointer is going to be come this side, right? Pointer is going to be here, and n2 as well. It's going to become this particular side. Now this is the remaining node. It's going to be t1. Temporary 1, and this is going to be 2, 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2 What is n1 dot next? 2. I mean 2 dot next, it's going to be 5, and 5 dot next t1, which is 3. And simple guys, very simple. Again, we just move the pointers. If I move that, it will look like this. It's going to become this side and n2 come to this side. Now what do we have to do? Just merge it again. n1 dot next, n2, very simple, and n2 is going to be 4, and n2 dot next is going to be empty, which is going to be null. And we obviously end up in the answer, and it's very simple algorithm, and I hope you guys understand this particular thing. Now let's write this pseudocode for this guys, and then we'll start coding up, and then I will give the outro and we'll close this video. So now let's write the pseudocode for this. Now let's start writing the first logic. First step, what we'll do is we apply two pointer techniques to find the mid element and then split array into two equal half. So first step is going to be find the mid. How to do that? Apply slow and fast pointer. So slow comma fast, it's going to be head. Initially both the things are going to be the head, and then now I'm going to apply the slow and fast pointer logic. So while fast and fast dot next. This is the case for slow and fast pointer. Again, if you don't understand, go back to the previous video, watch that and come back. So fast slow is going to move one step ahead. Slow is going to be slow dot next, and fast is going to move 2 times. So fast is equal to fast dot next. It's going to jump 2 steps. Now once we complete this particular loop, we'll end up in a midpoint. I mean slow is going to be stay in the midpoint. Now we need to get the second half of the list, because second half we are just going to reverse it. So second is going to be slow dot next. And if you don't understand, if we split, I mean right now the midpoint is going to be standing at 3, right? That's what we see. Slow is going to be standing at 3. Slow dot next is going to be the second half. That's why I took slow dot next. So slow dot next is going to be the second half. As a next step, what we have to do is we need to reverse the linked list, right? For that, what we can do is, I mean, before that, make slow dot next is going to be null. So slow dot next is going to be null. And now let's do the reversal process. So prev is going to be null or none, whatever, depend upon your language. Now let's apply the logic for the reversal. Now let's write the reversal part code, guys. And I'm going to write this very fastly without any explanation, because if you want explanation, go back and watch. So while second, now we're going to preserve the temporary, I mean the next section. So temp is going to be second dot next. And what we have to do now, second dot next is going to be mapped to the previous, and previous is going to become second. And then we just move the pointer. So second dot next is going to be previous, and now previous will become the second, and we just move the second pointer. Second is going to be temp. This is the very simple code for reversal of the linked list. Now what do we do? After reversing, we need to start merging it, right? So now let's do the merging part. Now for the merging part, we need to have the 2 pointers, right? One is going to be pointing at the head, and next is going to be pointing at the second, I mean the reversed node starting. So now let's write the code for that. The first is going to map to the head, the given head, and second is going to map to the previous. Now if we start writing the logic for the merging phase, so merging will be done until we finish the second loop, because always the second part is going to be equal or less than the first half. Always, all the case, it's going to be whether equal or it's going to be less than the second half. So it's better we can iterate till the second element it get finished. So while previous, and what we do, the same logic what we written over here. I mean while discussing we just written this, right? You can typically use this logic here. So let me write it out. What we did, first step, we just preserving, right? So temporary one, the t1 is going to be first dot next, and t2 is going to be second dot next. First step we just preserved it. What we did, third step, we just start merging things. First node to the next node, and next node will go to the t1. Then only the connection will become right? The first dot next is going to be second, and second dot next is going to be t1, and then what we did, we just move the pointers. The first is going to be T1 and second is going to be T2. Very simple. You can directly return. Actually, you don't need to return anything. Just simply, if we talk about the time complexity, it's going to be big O of n time. Even though we're just iterating 2 times, it always going to be big O of n. And the space is going to be big O of 1. We're just doing manipulation in the pointers. So we're not using any kind of additional space. I hope you guys understand this problem very well. And now let's code this up. Step 1 is going to be find the mid and break into 2 particular arcs. So find the mid. Now for that we are just going to apply slow and fast pointer technique. Slow comma fast is going to be head comma head, while fast and fast dot next. So we're just going to move. Fast is going to be fast dot next, and slow is going to be slow dot next. I just did small typo. Okay, now it's okay. Once this completed, it's going to come to the middle section. After getting a middle, we need to take the second up. So second is going to be slow dot next, and we just need to break the connection, right? So slow dot next is going to be none. That's it. Very simple. Now we need to do the second step. What is the second step? Step 2. It's going to be reverse second half. So reversal code is pretty simple. Preview is going to be none, and while second, so temp is going to be second dot next, and now second dot next will become pre, and pre will become a next, and we just move the second pointer. Second dot next is going to be pre, and pre is going to be second, and now second is going to be temp. That's it. Pretty simple. We just reversed it. Now the step 3, the last and final step, merging trace. This is the final step. For that, what we did, we have 2 pointers, the first and the second pointer. First is going to map to the head, and second is going to map to the previous node. I mean the which is the reversed one. Now what we did, while second, we just loop until the second going to get exhausted. So while second, and what's the initial step? We just preserve the 2 temporary nodes. So T1 comma T2 is going to be first dot next comma second dot next. And what we did next phase, we just swap the nodes. So first dot next is going to be second, and second dot next is going to be T1. And we just move the pointers. So first is going to be T1 and second is going to be T2. And at last, you don't need to return anything. I mean, they are specified here. Do not return anything. Just modify in place. That's it. Very simple. Now let's submit this and see. I mean, now let's run this. Yeah, it passed the test cases. Now let's submit this and see. Yeah, it passed all the test cases. Thanks for watching till this, guys. We'll meet again in one more video. Until then, bye.